Hey there, I got a question. What are we covering in this so-called math basics today?
I'm glad you asked. We are covering quite a bit, actually. Powers, roots, fractions, factorization, stuff that you learnt in elementary and middle school, but will surely come in handy for more difficult concepts, including that dreaded algebra.
Wow, that's quite a few topics. Why do we need to learn this?
You see, education is like one huge Jenga block. If the foundation is strong, you can build high towers. Otherwise, it all comes crashing down. Just like in your education, while most of you will be heading toward your grade 10 or secondary 4 exams, it is a good time to revise some of the old math concepts so you can learn newer concepts with ease.
Good old squares and roots. So, as you know, this means it's the square. Anything to the power, any number to the power of 2 is equals to squaring it. And you get 4. 3 to the power of 2 is also squaring it. You get 9. 4 to the power of 2 is also squaring it, and you get 16. So all this is simple enough. 10 to the power of 2 gives you 100. But all of these are positive numbers. What about when we have some negative numbers? 2 to the power of negative 2 is the same as 1 over 2 to the power of 2, which is 1 over 4. And similarly, any number to the power of a negative number is the same as 1 over that power. So you get 1 over 25. And it applies to really any number. So it can even be 1 over 3 to the power of 30. That's the same as 3 to the power of negative 30. One interesting thing is to the power of 0. So any number to the power of 0 gives us 1. Any number to the power of 0 gives us 1. And similarly, x to the power of negative of any number gives us 1 over x to the power of that number. So that is, not just squares, but also cubes and of both positive and negative numbers. So it's really quite straightforward. And if we were to talk about the roots, that's a bit of a different case. So let's say this is a square root, and this is a cube root, and this is the root by another number. So when you have a number which is squared, it means x multiplied by x. And if this is 4, so basically that number multiplied by itself, that's the meaning of a power. And depending on the number here, that's the number of times that it multiplies by itself. So if this is 40, then you'll have to multiply x by itself 40 times. Over here it's x squared, so it's 2, so you multiply it twice. And similarly, roots is actually just the reverse of it. So this is multiplying and this is dividing. And roots are basically a number dividing by itself that number of times. So over here, if you have 4, what multiplied by itself 2 times will give you 4. And if you have 8 here, what number multiplied by itself 3 times will give you 8. If you have 16 over here, what number multiplied by itself 4 times will give you 16. So that's really how square roots work. So 2 times 2 gives you 4. So therefore the answer here is 2. 2 times 2 times 2 gives you 8. Therefore the answer here is 8. 2 times 2 times 2 times 2 is 16. Therefore the answer here is also 2. So do you understand? Do you get the gist of it? This is how roots work. And it's the same for even in algebra context. So if you have this, then the answer is x, because x multiplied by itself 3 times will give you x cubed. Therefore, cube root of x cubed gives you x. Similarly, square root of x squared gives you x. And when it comes to square roots, you don't actually have to write the number. This is the universal sign for a square root, but when you write a number, then it just means the root of it that number of times. So this is a cube root, and this is a 4 root and 5 root and so on. And staying in roots, so this is actually written as the same as x to the power of 1/3. So whatever the number is over here, it actually becomes a fraction to the power of that fraction, and this becomes the denominator. So that's how you write a root in the form of a power. So if this is 60, this becomes y to the power of 1 over this number, 60. So basically a n, the formula is a to the power of 1 over n. So that's how you do it. So there are basically just 3 things for you to remember. Is a to the power of n. N is basically a multiplied n times, multiplied by itself n times. A to the power of 1 over n is basically root of n. And a to the power of negative is basically 1 over a to the power of n. Let's see, did we miss anything else out? I think that's just about it mainly. But if there's any other questions that you have on this topic, please feel free to comment below. So with that, let's try out some questions. So how do we write this out? What does this mean? What is the answer for this? Without using a calculator, are you able to do this? Are you able to do this without a calculator? And let's make this 8 instead of 3. And what is this as well? What is the answer? Tell me. Some more questions. What is the answer here? And what is the answer here? So if you can do all these 5 questions, then you totally have nailed it. And it applies whatever digits, and you can interchange these questions with any digits as well. So that's the whole part of it, or with any algebraic symbols as well. Cool. With that, let's go on to the next part of this.
Powers and roots. With great powers comes stronger roots. Ohm.
Roots of positive and negative numbers, similarly with cubes and roots. I also covered powers, roots, and the power of 0. So now let's go to do something a little bit more basic. Let's talk about fractions. So fractions, we know that 1 over 2 plus 1 over 2 equals to 1. That's because the denominator is the same and it's not difficult to do. But what if you have something where the denominator is not the same? How do we do this? Well, how we do this is we have to find the common denominator. We have to make both of them into a common denominator, and that's how we do this. So there's two ways to do it. One of it is we can actually find the lowest common multiple of these two numbers. Over here is quite simple. 3 times 2 gives you 6. So you just multiply it 2 times on just the left side, and you can do this question. So 2 times 2 is 4 over 2 times 3 is 6. So 2 over 3 is the same as 4 over 6. You plus it with 1 over 6 and you get 5 over 6. The other way of doing it is, let's try another number. So what if you have 3 over 7 plus 1 over 3? So 7 and 3, their lowest common multiple is really just 7 multiplied by 3. So you have to multiply it by 3 on the left side, 3, and you have to multiply it by 7 on the right side. So what you get is 3 times 3 is 9 over 3 times 7 is 21 plus 1 times 7 is 7 and 3 times 7 is 21. So you get 9 plus 7, which through just your mental sums you should be able to tell is 16. So the answer is 16 over 21. So that's really it. And you also have things like mixed numbers and improper fractions. So if you have 21 over 14, firstly you can reduce this. You can divide it by 7 because that's the common factor on the numerator and the denominator. So divided by 7 on top, you get 3. Divided by 7 at the bottom, you get 2. And this is an improper fraction because the numerator is larger than the denominator. Therefore, it is an improper fraction. And you can simplify this into 1.5. How I simplify this is because 3 over 2 is basically 2 over 2 plus 1 over 2. 2 over 2 is 1 plus half gives you 1.5. So these basics, you may be thinking, well, it's so simple. What am I going to do with this? But it really comes in handy when you're doing things like, say, algebra. So because when you have algebra, let's say you have x plus 2. And let's say you have something like y over 2 minus 2 minus x. How do I do this? Well, it feels like you jumped from primary 1 to primary to secondary 4 just like that. No, actually, you have to know that x plus 2 minus 2 minus x. If I take out the negative 1, I get 2 plus x, don't I? I get 2 plus x. And 2 plus x is the same as x plus 2. So I can take out the negative 1 and I can do this. And when I take out the negative 1 over here, then I can take out the x plus 2 just like that. And I have x minus y, because I actually have x times over minus 1. And this becomes y divided by negative 1 is negative y. So I basically have x minus y divided by x plus 2. So you see, from just a simple learning about proper improper fractions, I can apply it to a topic like in algebra. So foundations are really important because that really helps to determine how quickly you can grasp other applications that you come across. What else is important in fractions? Let's see. Okay, let's try another one because I think this might be a little tricky. So y minus 3 plus, okay, let's just do a plus over y over 3 minus y. They look so similar, but they are not the same. So how do I do this? So x over y minus 3 plus y over, take out the negative 1, and you get minus 3 plus y, which is the same as x over y minus 3 plus y over negative 1 y minus 3. Ta-da! So you have a negative 1 and you might as well just put it on top. So we get x over y minus 3 and bring this negative 1 on top. So we get plus negative y over y minus 3. X plus negative y is the same as x minus y. So you get x minus y over y minus 3. That's the answer. And that's how you do fractions.
Hey, you again. Just priming myself for that prime factorization coming up.
Prime factorization. So let's say you have a number 51. So how do I show this as sum or multiplication of its prime factors? So what are the numbers that make up 51? So 3 multiplied by 17 gives you 51. And can we break 3 further? No. Can we break 17 further? Because these are all prime numbers. So therefore 51 equals to 3 multiplied by 17. So this is how you showcase a number by its prime factors. Let's have another number 30. So 30, you can break it down by 10, by 3. 10 can be broken down by 5 and 2. 3, no, that's it. So therefore 3, 2, and 5 are the prime factors in 30, and it's equals to 2 times, always in ascending order. That's how you do it. And we can do it for even larger numbers. Let's say you have 120. You can start 60 and 2, 30 and 2, 15 and 2, 5 and 3. So all these numbers that cannot be divided any further, they are your prime factors of 120. So this will be 2, 1, 2, 3, 2 to the power of 3 times 3 multiplied by 5. And this is what you call a factor tree. It's quite simple, really. And you can do this for any numbers, really. Let's do a difficult one, 250. Let's say 50 times 5. So 5 is a prime factor, so no more. 5 and 10, no more there. 5 and 2. So this is really 2 multiplied by 5 to the power of 3. That's all. That's really how your prime factorization is done, and this is your factor tree.
Well, these basics have piqued my interest. I continue on my path to uncover more great math basics. As they say, a strong math foundation leads to a solid math understanding.
To your interest as well. As always, leave any comments below if you have additional questions that you'd like to clarify with me, or you need explanations on any of the working, or even if you have any homework that you need some advice on. So feel free to comment below. Subscribe if you liked this video, and as always, please give me a thumbs up. Thank you. This has been Mango.